Hi there, I'm Hao, and this is just another video of me solving random decode problem. So let's begin. Populating next right pointer in each node 2. Okay, so we have the root tree or the binary tree, and we need to return binary tree, right? But each node gonna have a next pointer, right? So the default next pointer gonna be no, I believe, right? And so we need to set the next pointer up each node like this. So the root you're pointing to. So okay, so populating the right pointer on each level is the right way to think about it. So it makes more sense to just look at it level by level, right? So if the number one here, right, doesn't have anything on the right in its same level, then it's gonna be no, right? The next pointer, right? Here, right? The two here, we can point to the three, and the three we can point to no, right? On the last level here, right? 4 point to 5, 5 point to 7, and 7 point to no, right? So this look like a breadth first search traversal to me. So we can use a queue to do that, right? So at any point in time, right, we're gonna have our order length equal to 1, right? Our queue, we're gonna have the root rate, which is what is it? 1, and then at level 0, right? Okay. Um and then yeah, I mean that's pretty much it's right. We just have a queue, right? We're just iterating over every single element, right? So if the current length is 1, we're iterating uh, one time, right, over the current level, which mean which means that the current level at level 0, the current level, right, only have one element, which is the routine, right? So if we are at the um, last element, right, we just don't do anything, right? Because as you can see, the last element, right, never have a next pointer. It's just gonna be no. Okay, so we only set for the index that is less than the last index. Okay, so yeah, as usual, we pop it off, right, at the left and the right child. So 2, the next level, of course, at level 1, right, 3 at level 1, right? So now our current length going to be 2, which means and the current level going to be 1, right? Because the peak going to be 1 here, right? So there will be 2 elements on level 1, right? 2 elements on this level. So we just iterate through and pop it off, right? So we pop this off. We pop this off, right? Right. So is this the last index? No, it's not the last element on the level, right? So which means if we have an next pointer, right? So we can point this to whatever uh is at the peak of the queue, right? The three element here, right, is the element at the peak of the queue, which means it is the element that is about to be popped, right? At the next iteration. So we can set the next pointer to whatever element is at the peak of the queue, right? So we put this to that, right? And then now, yeah, we pop this off. Also, we pop this off, right? But it is the last element, right? Index 1. So we just don't do anything. So it doesn't have an next pointer, right? And of course, when we pop it off, do not forget to add in the left and the right child if we have one, right? Okay, so the next element gonna be 4 at level 2, right? 5 at level 2, and then 7 at level 2, right? So now we have 3 elements on level 2, right? Okay, so we pop up one by one, right? 4 and 2. Okay, we pop this off. And it doesn't have any left and right child, right? So that's good. Okay, it is the last element on the level, no, right? So we point this to next pointer to whatever is at the peak of the Q, right? Q is first in, first out, right? We add from this side and we pop from this side. Right? So at the peak, gonna be 5 and 2. Okay. So now we pop this off, 5 and 2, right? 5 and 2, right? 5 and 2. It doesn't have any left and right child, so that is good. And it is the last element on the level. Not really, right? One more. So we point into the peak element at the cube. Okay. And then we pop this off, 7 and 2. 7 and 2. Right. It does have any left and right child? No, right? And it is the last element on the level. Yes, so we don't do anything. Which means the next gonna be according to no. Okay. So that is our reason there. I have a custom queue here, so we can have shifting in all one. Right. So when I have a queue, go to a new my queue. Okay, and we need to return the root at the end. Right. And then we need to push in the root chain at level 0. Okay. And why q.length, we're gonna do something, right? Okay, so this is our basic structure here. And remember, we're gonna have a special case when the root is no, because well, you just want to return the root. Because the number of nodes can be 0. Okay. So always pay attention to the constraints there. So you want to pick up the current length, right, which is q.length, right? So iterating over every single element on the current level, right? The node gonna be equal to q dot pop, right? So if it is the last element on the level, right? If it is the last element, we can index when equal to current length minus 1, right? If it is the last element, we don't do anything, right? But if it is less than, right, the last element, if it is not the last element on the level, right, we will index is less than current length minus 1, and we want to set the node at next, right? The next pointer equal to whatever is at the peak of the queue, to the peak, right? And yes, because we don't want to we don't care about the level in this case, right? I draw out the level over here just so that you can have a better visualization, but we don't need it, right? So the peak here is just gonna be the node, right? And after that, we need to add the left and the right element style. Like if we have node left, we're gonna push the left. Otherwise, we have the right. So we're gonna push the right, of course. And yeah, this is pretty much it. Okay, root, not total, the typo there, and it worked. Thank you for watching.